this video, we're going to take a look at how to program in C# the 15 sliding piece puzzle game. You probably have played this game before. There are 15 numbered tiles and a blank tile, and the goal is to get them in ascending order. So let's go ahead and get started. So the first thing I'm going to do with my form is I'm going to change the back color to black. You can change yours to whatever you prefer. Now we need 16 picture boxes, but before we go ahead and add 16 picture boxes right away, the first thing we're going to do is put one picture box on here, get it the size that we want it to be, and then we'll copy and paste. So we're going to go ahead and make this. I feel like that's pretty good, and we'll resize our form in a minute. You can make yours any size you want. I'm going to change the name from picture box 1 to pick 1. Now this doesn't refer to the number tile 1. We're not actually moving this picture box around the board. What we're actually going to do is we're going to make this an array, and we're going to load different tiles into picture box 1, picture box 2, all the way to 16 based on what tile is there. If you don't know what I mean by that, you will momentarily. After we change the name, the last thing I want to change is size mode, and I want to change that to stretch image. That property will now apply to all the text box or picture boxes that I make. So I'm going to get picture box 2, put it right next to it. Here's 3, here's 4. Then I'm going to go ahead and select all of these, and I'm just going to copy and paste. That way they're all the same size. They're all lined up. I can make my form a little bit bigger. There we go. And now I have all 16 picture boxes. And the reason I'm not a big fan of just doing pick 1, pick 2, pick 3, and so on. The reason I'm numbering these is so I know the position of each tile. It's going to be a lot easier to understand if we do pick 1, pick 2, pick 3, and pick 4 across the top row, and then pick 5, 6, 7, 8 across the second row, and so on, all the way down to 16. So let's go ahead and skip ahead to where all these are fully numbered. All right, we have all 16 picture boxes. They are numbered correctly. You may want to go and make sure yours are numbered correctly, because if they are not, that could create an issue later on. The last thing we need to do is change the text property of Form 1 from Form 1 to sliding puzzle, making it look a little more professionally. The graphical user interface part is done. Now we can move on to the coding. If you want to front load these picture boxes with an image, you can. I'm not going to, because as soon as the game starts, we're going to randomly put a tile into each position. So we'll see all that in a minute, but let's go ahead and let's start declaring our global variables we're going to need for this 15-piece sliding puzzle game. All right, the first global variable we're going to need is a 2D array, and that's going to be a map grid. Now, when you're setting up a 2D array in C#, you're going to put a comma inside this first set of brackets. You're going to give it the name map grid equals, you're going to do new int again, and then how many rows followed by how many columns. Now, if you're coming from another language, it's very important to understand that this 4 does not represent the max index. The max index is going to be 3 because it starts at index 0. The next thing we need is a list of ints, and the reason that is so we can hold all the numbers that we're going to generate. So we're going to do new list int. We're going to put our parentheses and then a semicolon. The next thing we're going to need is a 1D array of temp nums. Now this temp nums is to see, is the game winnable? Not all setups are winnable, and that's to count inversions. So what we need is we need a 1D array of temp nums so we can count the inversions. And then what we need is the goal. Now, there's a couple different ways you can do this. For me, I think setting up the goal of what we want is best. So I want it in this order: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and -1. That's the goal now. -1 is going to be the blank space. So when I get all my tiles in ascending order and the blank space at the end, I know that I have won the game, and that is the purpose of the goal. There are a few different methods we need to build, so let's take a look at those now. All right, so let's go ahead. Let's build our list. So we're going to do private void build list. Now this is the list of numbers we are building, and we need to build the list because not every startup or setup is solvable. So we may need to build this list more than one time. So that's why we made it a method. So if you're like, why don't you just put it in form load? Because it may be possible that when we set up the first iteration of the game, it may not be solvable. And we're not going to give the user something that can't be solved. So we're going to do for int I equals 1, not 0, because we are going to load the numbers in. So let's do this. Make sure we're keeping it looking nice and formatted. All we need to do is all nums. What are we adding? We're adding I. So then we can add all the numbers. Now, because we don't have -1 there, we're also going to add -1, and that is for the blank tile. And add is spelled with 2 D's, not 3. Okay, perfect. Let's go ahead. Let's add an extra one there. So we opened it. We need to close it. There we go. All right, keeping it formatted nice. The next one is a Boolean method. It's going to return a Boolean value. So we don't want to make it void. It's going to return a Boolean value whether the game setup is valid or not. And that's based on a couple of things. Now, there's some variables we're going to need here. We're going to need index, and we're also going to need a random value to select a random index. That's for the list. We only want to pick the number once, so we need to select a random index from our all nums list and then remove it as well. We need to know where the blank is located, specifically what row. We need to know how many inversions there are. These two things go together. It's dependent on where the blank tile is located, what row, and then how many inversions there are. And you'll see all that in a minute. And once we have that, we have our blank index. All right, so those are all the variables we need. All right, we're going to take a look at our code. I'm going to explain it to you, and you can copy it down, so feel free to pause whenever you need to. So we're going to start with this first for loop. For int I equals 0, we're going to run it as long as I is less than 16. We're picking a random index number. That's why we have R&D num. We're going to pick a number between 0 and 15. All nums.count is holding 16 values, but remember, it's going to be 15. So including -1, and we're picking the random index, not a random value. So it's very important there. We're storing that in index right here. All nums, we're accessing whatever that random number is, whatever's stored at that index, we're going to put inside temp nums. Then we need to remove it. We want to use dot remove at, not remove. Dot remove will remove the specific value instead of what's actually stored at that index. So you want to use dot remove at. If it's our blank tile represented by -1, we're going to store that because we'll need that momentarily. So this entire for loop, all it does is build a randomized 1D array of our values. Why do we need that? Because the next part we need to do is to count inversions. And that's what this nested for loop does. Imagine I have the following numbers: 3, 1, 2, and 4. I start at index 3. That is, or not index 3, the value of 3, which is our very first number. I check the number next to it if it's not -1, because -1 is our blank tile. Of course, -1 is not going to be greater than any other number in the list. So there's no point in checking the rest of the list if we're at -1. If we're not at -1, so if we have 3, 1, 2, 4, 3 is greater than 1. That's an inversion. 3 is greater than 2. That's an inversion. 3 is not greater than 4. That's not an inversion. My total number of inversions is 2. Then I've already checked 3, so now I start at 1. This is when this I increments again. I check the number next to it. I don't start back over at 0. 1 is not greater than 2. 1 is not greater than 4. I'm still left with a total number inversion of 2. and we keep adding it. So we only increment if the number we're at is greater than the next number that it checks, and this keeps looping until we get to the end of the array, and then we move to the next number, as long as it's not -1. We don't need to compare whatever index we're at for this outer loop to -1, because obviously that will count as an inversion. That is not how the check when actually works. Let's take a look at the check when condition here. So, or if the game can be solvable, not check when. We got to find out, is the game solvable? Well, we need to know how many inversions there are. We need to know where the blank tile is. So we stored the blank index. We're going to divide that by 4, and whatever that value is, we're going to do 4 minus blank index divided by 4. Why are we doing that? How does that work? Because when you're doing the check, or you're checking the condition to see if the game's solvable, row 1 is actually at the bottom of the grid. It's not the first row. It's actually going to be the 4th row. That's row 1. Row 2 from the bottom is the second to last row. Row 3 from the bottom is the second row. 4 rows from the bottom is the 4th row. That is the condition to check to see, is the puzzle that we generate, is it solvable? Now, there are 2 different ways that it is solvable. If the blank tile is on an even row, then we need to make sure there's an odd amount of inversions. And that's why we're using this modulus operator. If it's even, it's going to have a remainder of 0. If the inversions is odd, it's going to have a remainder of 1. That's one possibility. If the tile is on an odd row, then we want to make sure there's an even amount of inversions. As long as one of these 2 conditions are true, we're going to return true, saying yes, it is solvable. We can use this grid layout. If it returns false, we need to generate again. So we're going to do a loop in another place that keeps calling this method until it does return true, saying, hey, we have a grid that is solvable. Let's take a look at the next method. Once we have a grid that is solvable, we can go ahead and go ahead and set the grid. So we're going to do private void set grid, because we have a layout that is solvable. So all we need to do now is set it. We're going to need a couple of variables. We're going to need value, and we're going to need index. And then all we got to do is use a short for loop here. We're going to start for inti equals 0. And then I less than 4, because we're going to be setting up the 2D arrays, and there's only 4 rows, index 0, 1, 2, and 3. Because it's a 2D array, we're going to need a nested for loop. So we're going to do j. As long as j is less than 4, because there are 4 columns, then we're going to do j++. Now all we're going to do is take that 1D array and store that inside value. So I'm going to do temp nums index. That will give me the specific value. Then in map grid ij, what are we going to put inside there? We're going to put that value, and then we're going to increment the index. Now, if you don't like having a bunch of values, you can do map grid ij equals temp nums index. I feel like this is a little easier to read. I'm getting that value. I'm taking that value, putting it in the 2D array. If you want to get rid of value and you want to do this in one line, you can. It's up to you, but that's the whole method for set grid. All right, we're going to set pictures. We're almost done, almost ready to check the game and get it to win. We create an array of picture boxes, and that's all the picture boxes we created earlier. Pick 1, 2, 3, and don't forget 16. Pick 16. Very important, because we got to put that blank tile or whatever is inside picture box 16 on there. So make sure you include all of them. We have pick index equals 0, index equals 0, string image name. This will save us a lot of headache trying to load these array of picture boxes, and value equals 0. Now we're going to run a nested for loop, because what we are trying to do here is take whatever's inside that each value of the 2D array and then load the correct image. So I'll show you how to do that I'll show you how to do that now, but then we got to load our images, and I'll show you that next. So we have our nested for loop here. I'm getting the value as I traverse through the 2D array. If the value is -1, then I know my image file name is blank. So I named my files blank 1, 2, 3, 4, all the way to 15. The 16th picture being blank. Then I load image name. If it's not -1, well, then I'm going to use an underscore, because when I load pictures into Visual Studio, if it starts with a number, it puts an underscore in front of it, because file names, when you import them as part of the resource, are not allowed to start with a number. So it puts an underscore in front of it. Well, I don't want to type in ONETWO. I want to have the exact number. It's easier for me to work with. Then, because it is a number, I want to convert it to a string, because value is an int. So when I concatenate it with this underscore here, I want to convert whatever that value is to a string, so it can read it as a actual image file name. So it picks index starting with index 0. Dot image. What am I doing? I'm creating an image. Where is that image located? Well, it's in my resource manager, and I want to use dot get object. What object am I getting? Whatever that file image name is, and that's going to load the image. Then I'm going to increment index. The next thing I need to do is use the tag property of this array. And what that is doing is it's allowing me to add extra data. What new data am I creating or tacking on to that picture box? Well, I'm creating a new point, row, and column, which the first one's going to be 0, 0. It's that row 0, column 0. We'll need this for a click event. And here's my click event. I'm going to take that index.click. I'm adding it to the tile click event, meaning when I click on that picture, it's going to run whatever code is in here. You can ignore that red line. It's temporary. It will go away as soon as we code out the tile click event. And then I simply increment pick index, so it goes to the next one. This will run through every value in my 2D array, assign the correct image based on the 2D array, and then get the row, assign it a row and column. And .tag just allows you to add some extra data that it may not have. So when I do it as a new point, I'm creating a point data, assigning it a row and a column, and that's so I can switch the blank tile with whatever tile is nearby that I'm trying to move. I need to know what row, column it's at, and you'll see all that in our tile click event. Let's go ahead and take a look at the tile click event code so we can code that out. So in my tile click event code, we're going to remove this set of parentheses. We did not need it. Now we have our tile click event, so that red line is gone. Let's take a look at the variables we're going to need. Row, column, and new column. So in these for loops up here, I used row and column, so it's a little easier to read if you're a beginner, because row and column is much easier to understand than I and J. But if you are have coding experience and you want to use I and J, feel free to do so. Beginning back to this click event, I'm creating a picture box clicked pick. What is that going to be? That is going to be the picture box that we actually click on, and we're going to rename it clicked pick. So when you see clicked pick, what is that representing? The picture box that we actually clicked on, because there are 16 picture boxes that we could click on. So we need to make sure, or instead of having 16 methods that are identical, we can create our own custom one, and that's what we have done here. I get its position, because remember we had that tag property, tacking on extra information to that clicked pick. It's getting the point, and I'm putting that into position, and I'm storing its row and column. So the row and column, what is that representing? It's representing the row and column that this picture box is on. Then I create an array of directions. This first point, -1, 0. What is that going to do? That's going to change the row by moving to a previous row, staying on the same column. What about this 1, 0? That means moving down a row, staying in the same column. 0, -1, staying on the same row, but moving left 1 column. 0, 1, staying on the same row, moving right 1 column. I'm going to traverse each of those directions, and I call it direction. Point direction. Point is my data type. Create a variable called direction, and it's going to represent each of these as it goes through. That's what a for each loop does, traverses the entire thing. So my new row is my row plus whatever the direction X was. My new column is going to be column plus whatever direction Y is. This is X, this is Y. So we're checking each of those. Now, if the new row is greater than equal to 0, and the new row, and it's less than 4, and it's greater than or equals 0 and the column is less than 4, then we're in bounds. Because we're in bounds, we're good to go. We check the map grid. Is it going to be -1? If it is, then my new row and new column, what am I putting there? I'm putting what the old value was. It's allowing me to swap -1 and that other value, because the only way I can swap tiles is if the blank tile is above, below, to the left, or to the right of it, and that we're in bounds. What am I putting in that original position? Then -1. Then I'm going to set pictures, check the win, and then I'm going to break. If this one works out, if this if statement is satisfied, I don't need to check the rest of them. So break allows us to exit that loop early. We call check win before we break though. And we got to check to see, is everything in the right place? Because if it is, then we've won the game. So we run a nested for loop. If you want to use row and column instead of I and J, you can. Use whatever you feel more comfortable with. If the row and column of our 2D array is not equal to the goal index, then we don't have it in the right place. We're simply going to return, which allows us to exit this method early, because there's no point in checking the rest if one tile is in the wrong place. If it's in the right place, we're going to increment index and we're going to continue checking. If we can make it through this entire nested for loop without hitting this return statement, meaning everything is in the right place, then we have won the game. So that are the next two methods that you will need. All we need to do is load pictures into our resource folder, set up our form load to call a couple methods to get it set up, and then we can actually test our game and see if it works. All right, let's go ahead and add our pictures. So at the very top, you're going to click on Project. You're going to scroll all the way down, and you're looking for whatever your project name is, properties. So I called mine ECS Sliding Puzzle Tutorial. Click on that, you're going to see this screen. Select Resources. You're going to see that on the left-hand side. It'll probably load to this screen. Just change it to Resources. Change strings to images. When you click on this down arrow for Add Resource, you're going to add an existing file. Mine is in my Pictures folder. So here's my slide puzzle. And there are all my numbers. Now, notice this file is 1. When it gets added in, it's going to put an underscore in front of it. So you're going to see that because we can't start a file name with a number. So if you look closely, you'll see there's an underscore under all these numbers. And that's why we concatenated that underscore with the file name that we did earlier. All we need to do now is we need to go into our form load event. There's very little code we need to write. And what we need to do is we need to check, okay, did we build a valid puzzle? Is it solvable? So I'm going to create a Boolean value called valid game. I'm going to set that equal to false. Then what we're going to do is we're going to use a loop. So we're going to type in do. I'm going to open and close my curly brace. I'm going to call build list, because that's going to build the list that we can randomly select values from. Then I'm going to do valid game equals, and then I'm going to build that array. Because when I build the array, it's going to return either true or it's going to return false. Now, I want to do this. I want to do this while, which is our condition, why we don't have a valid game. Once we have a valid game, we don't need to do it anymore. Once I have a valid game and it's solvable, I need to set my grid, not set grid 0, just set the grid, and then set my pictures. And after that, everything is good to go. So now we're going to go ahead, we're going to save. Let's go ahead, let's run our game and test it and make sure it works. Okay, here is our solvable puzzle. Take a look at my 11 and my 10 here. You can see there's a little bit of white when I edited the numbers in paint. I didn't go all the way with the background, but that's okay. It's simply aesthetics. We're checking our code. So let's go ahead and get this moving. So if I click on other numbers, nothing should really happen. All right, the values are moving, so that's good. Let's get this 1 up here. So it needs to be first. So I'm just clicking on those numbers that I want to move. Need to move that 2 up as well. Perfect. Just shift everything around there. We want to get this 2 over here. That's not going to work for me. So what we'll do is we'll shift all this around. And it just takes some problem solving. That's all it does. Just some problem solving. And we can shift this down. Let's see here. Let's shift this around. There we go. Okay. Now the 3 and the 4, that's a little more tricky. You can't put the 3 where the 5 is just yet. Let's move this back here. I want to get that 3 in the upper left-hand corner. And you'll see why I want to do that in just a moment. So I'm going to get that 3 in the left-hand corner. Perfect. Now, or the right-hand corner, not the left-hand corner. This is the right-hand corner. And I want to get that 4 all the way on the other side of the screen. Now this is the left, the bottom left. Do you know my my number or my directions here? Okay, just going to move this 4 all the way across. I want to get it in the bottom, right underneath the 3. And here's why I want to do that. When I move this 13 down, I can move this 3 and the 4 is on the right spot. I need to get this 5 in the right place. Don't need to go too far with the 5. So we're going to move this down. Probably taking the long way here to do it. Move this around, move this 5 up. There we go. Okay, so the 6 and 7 will go over there. The next number I'm looking for is a 9. So I'm going to move this 9 up right below the 5. And then I'm going to need to do the same thing with the 13. Actually, I need to do that now because I don't think that's going to work. I'm going to need to move the 13 over here. That way when I shift the 9 up, the 13 will follow it. Almost like linking them together. So move this 13 over. Because once you get the first row and the first column set, you're good to go. All right, I'm going to move this 14 over, move this 9 up, 13 over. Perfect. Now I've taken a 4x4 grid and I've made it 3x3. So for the 6, I can do the same thing that I did for the other ones. I can just move it in. There's 7 and 8. Perfect. I need to get that 10. And this is why you need to make sure it's solvable. This is why you need to make sure it's solvable. If it's not solvable, it is possible that this set of numbers that we have here in the 2x3 grid that we're left with, that they're set in such a way that it can't be solved. So we want to make sure it's solvable. So I need to move that 12 up. So I'm just going to move this. Oh, actually, it's the 11. That's what I need to move. So I'll move this 10 down, this 12 over, this 10 up. Let's see here. There's only so many ways you can go. Let's see here. Move that 10. Move this 12. Oh, move this 12 down. 11 over. 14 up. 12 down. The 12 up. Move the 11 back. And we just gotta have to keep, cycling this until we can get it. So a little bit of problem solving here. Have the 11. Okay. So let's see, 11, 12. Okay, that's not going to work. Let's try moving this 10 around. Okay, 12, 14. There we go. There we go. Now, when we move this 15, everything should be in the right place. And we have won the game. That is how you solve the puzzle game. We know that it works correctly. Everything's in the right order. We have that blank space. We had a solvable puzzle, and we were able to solve it. Took some, problem solving there at the end, but that's how you solve the 15 puzzle piece. I hope you guys found this video helpful. If you did, please take a moment to give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.